Welcome to Class TV. I name myself Alewi Tosin. Now, this is part 7 of this great topic we've been taking, equilibrium of forces. Now, let's take a worked example on this. The example goes thus: from the center of a ruler, let's have this as a ruler. This is center. In the center, let's have our fulcrum placed at the center. I said it in my previous class that the center of a ruler or a meter rule will be what? 50 centimeter, because the length of a full meter rule is 100 centimeter. Okay, so this place should be 50 centimeter because the full length is on 100 centimeter, and mass M is hung 20 centimeter away from the center. Now, away from the center, this place will be what? 50 centimeter. Then 20.5 centimeter away should be somewhere around here. It should not be up to half. It should be somewhere around here. So that's where it is hung. So let's call this place what? 20.5 centimeters. Okay, that's this place to this place, 20.5 centimeters. Now, a mass M, which is an unknown mass, is hung there. Okay, now the now said that what? And a mass is 0.1 kilogram is hung at the other side. Is 0.1 kilogram is hung at the other side. Now that means that what? The other side, they did not tell us the point where it is hung there, but they said it is at the other side. So at the other side, we are having a known mass. And the known mass now is what? Is 0.1 kilogram. That's the known mass. Okay. Now the question now says that what? Okay, you are even told that it is from the center of the ruler, 45 centimeters. Okay, in that case then, so 45 centimeter will need to be extended this way, because this should be like, that means this part now is 45 centimeters. Okay, because we were told that what is 45 centimeters from the center of the ruler. Now the question now goes thus. The question says what? We are to find the mass required to balance the ruler, which means for this ruler to be balanced, which mass should we place here for this ruler to be balanced? Normally, you know, for this to be balanced now, the sum of clockwise moments must be equal to the sum of what? Anti-clockwise moments. So which means we are saying that what? Our M1 D1 must be equal to M2 D2. So on that note now, we can say that what? Our M1 is unknown. Our M is unknown. Let it be X. Okay. And our D1 is 20.5 centimeter. And for this other side now, you can say that our M2 is 0.1 kilogram. Let's convert this to gram, just because our this was also in 1 centimeter, depending on the question though, depending on the option given, if it's an objective question to determine but normally this is the SI unit for mass. Okay, SI unit for mass. Let's just say, let's leave it this way then. So this becomes what? And our D2 will be what? 45 centimeter, 45 centimeters, right? So we say that what? Using M1, D1, our M1 is X, our D1 is 20.5 equals to what? Our M2 is what? Is 0.1 and our D1 is 45. So we can just leave the unit for distance as centimeter because it is a concept of what? Proportionality. Now, so we say we are dividing through by the quotient of x, which is this, so that this cancels this now, right? So with this now, we say that what? Our x will be equal to 4.5 multiplied by what? 20.5. With that now, our x will give us what? So that will give us 0.22 kilogram. So that will be the mass that will be on here for us to have the ruler what? Balance. Now you will notice something here that what? That the mass that is on here, for it to stand, the mass will be lesser than, okay, the mass that will be here will need to be higher, bigger than the mass that will be on here, because the distance here, D, is more than the distance here. So the distance has a certain relationship with what? With the mass that will be on here. So that is all for that the question. We take more examples in our next class. I am myself, Aliwi Tosi. Thank you.